Okay. So we're back again, and it's with the Edexcel paper, and it's paper 3 of June 2022. It's a calculator paper. So we're going to do answers coming up on the screen with solutions, and then I'm going to explain what I did and the topic you should be thinking about that's related to the question. Okay? Let's get into it. Okay, so the topic is Pythagoras theorem, because that's a right angle triangle. So you have your longest side, which is your hypotenuse, and then you have the other sides. Okay, and the formula is hypotenuse squared, the longest side squared, is equal to the square of the other sides, and you add them together, so a squared plus b squared. You can call any one a or b, doesn't matter. The main thing is the other sides squared and added together equal to the longest side squared. So 8.5 times 8.5 is equal to 4 squared, which is 4 times 4 plus x squared. And so that's just straightforward. So 2.5 equals 16 plus x squared. Then you move 16 to the other side and subtract it. That's 56.25, and you square root both sides. X is equal to 7.5 centimeters. Easy peasy, straightforward. Okay, question 2. So we have t equals 4m squared minus 11. Work out the value of t when m is equal to minus 3. Okay, so anywhere you see m, you put in minus 3. And so m squared, you put in minus 3 squared, which would be minus 3 times minus 3. And you have to do that first. It's still the rules of BODMath or BIDMath. It's still algebra. So minus 3 times minus 3 first. That will give you plus 9. And then 4 times 9, that's 36. Then minus 11, you have 25. Okay. Now part B says, make P the subject of the formula. D is equal to 3P plus 4. Okay, so subject of the formula is like working BIDMath backwards. So first thing we got to do, because to get P on its own, we get rid of 4 first. So we subtract 4 from both sides because it's added to the right. So we subtract it from the right. And so we do that to the left as well. So we have d minus 4 is equal to 3p. Some people prefer to just carry it over and then change the sign as it crosses over the equality sign. That's also fair. So d minus 4 is equal to 3p. And then you divide both sides by 3. On the right, 3p divided by 3 would just be p. And on the left, you divide the whole thing. So d minus 4, all divided by 3. That's why I put it in a bracket, because it's the whole thing, not just the 4. Pretty straightforward. The topic is subject of the formula. You want to brush up in the textbook and look at examples. That's what it's all about. Okay. Okay, question 3. Rick, Selma, and Tony are playing a game with counters. Rick has some counters. Selma has twice as many counters as Rick. Tony has 6 counters less than Selma. In total, they have 54 counters. The number of counters Rick has ratio the number of counters Tony has is equal to 1 ratio P. Work out the value of P. This is a Ratios and algebra related question. Two different topics pulled together. Okay. Okay. So it says Rick has some counters. Selma has twice as many counters as Rick. So we're relating what Rick has to what Selma has. So we start with Rick. So if we say let Rick's counters, since we don't know, let that be X. So Selma has twice as many counters as Rick, so that'll be 2X. And then Tony has 6 counters less than Selma, which means that Tony's counters will be 2X minus 6. Okay? And it says in total they have 54 counters. So we just add X plus 2X plus 2X minus 6. And that just becomes a simple linear equation. X plus 2X plus 2X, that's 5X minus 6 equals 54. Collect like terms. You add 6 to both sides. 5X is equal to 60. And if you divide both sides by 5, X is equal to 12. Now, remember X represents Rick's counters. That's 12. We don't need to know what Selma has. We need to know what Tony has, because that's the ratio we're looking for. Tony has 2X minus 6. We know X is 12, so that'll be 2 times 12, which is 24, minus 6, which is 18. Now, we can do the ratio. Rick to Tony's counters, 12 to 18. We reduce at the first stage, that's 2 to 3. And because we need Rick's portion of the ratio to be 1, we divide by whatever number that is for both of them. 2 divided by 2, that's 1. 3 divided by 2, that's 1.5. That's 1 ratio 1.5. Okay? Remember, it's a calculator paper. So, if you're struggling, you could easily have just divided both of them by 12 on your calculator. And you get 1 ratio 1.5. Okay? Remember, the topics here, a bit of algebra, linear equations, and ratios. Okay? Okay, question 4. Joe is going to buy 15 rolls of wallpaper. Here is some information about the cost of rolls of wallpaper from each of 2 shops. Chic Decor, 3 rolls for £36. Style Papers, pack of 5 rolls, normal price £70, 12% off the normal price. Joe wants to buy the 15 rolls of wallpaper as cheaply as possible. Should Joe buy the wallpaper from Chic Decor or from Style Papers? It will show how you get your answer. Okay. This is basically everyday math. Okay. Okay. So, Chic Decor, if 3 rolls are for £36, 15 rolls, that's 5 times 3, so that's 5 times £36, so that's £180. For Style Papers, it says pack of 5 rolls is £70, so you do that 3 times, you get 15 rolls. 3 pack of 5 rolls will give you 15, so that's 3 times 70, that's 210, that's the normal price. And then you apply the discount, so 12% off the normal price, which is 1 minus 0.12, so 12% of the decimal, times the normal price, so that's 0.88 times £210, and it gives you £184.80. Okay, now some people might decide to go 12 percent of 210 first, and then subtract that from 210 to get the discounted price. But I just needed discounted price, so I didn't solve for the reduction. The point is, Star Papers is still more expensive than Chic Decor, so I have to state this, that Joe should buy from Chic Decor because it is cheaper. And I'm stating how much cheaper. £4.80 cheaper. Okay? Just goes to show you, because there's a discount, doesn't mean it's cheaper. Okay, question 5. The table gives information about the length in centimeter of some pieces of string. So you have the length in range and frequency. Amos draws a frequency polygon for the information in the table. Write down 2 mistakes that Amos has made. So, this topic is about frequency polygons, and anyone who knows anything about frequency polygons is to plot a frequency polygon. You plot the frequency against the midpoint of the range. So, the midpoint of 0 to 10 would be 0 plus 10 divided by 2. So that would be 5. Okay? And so on. Okay. Now that we've found the midpoint of every length, and we specify the plot points. So the midpoint for that one is 5. So we plot 5 to 15. Okay, that's correct. Second one is 15 to 20. That's correct. Third one, 25 to 50. That's correct. The only problem is, if you look at the graph on the left, the scale is wrong. So it goes from 10 to 20 for 2 boxes to 30, and that goes to 50. That's wrong. It's supposed to go to 40 and then up to 50. That scale is wrong. So one of the comments is the frequency scale is inconsistent or incorrect. And then if we move on, 35 to 25, that's correct. The last one is supposed to be 45 to 5, that's 50 to 5. That's wrong, so it's in the wrong position. So those are our 2 issues. Okay, and so those are 2 mistakes outlined. The frequency scale is inconsistent. It's supposed to go 10 to 20 to 30. Where it's 50, it should be 40. Where it's 60, it should be 50. And the second thing, the last plot point is not correct. It should be here, 45 to 5, not 50 to 5. So you outline that, show your process, and you should be fine. Okay? Things to always check on a graph. Make sure the scale is correct and consistent. Make sure all the plot points are plotted correctly and the right line is used. For a frequency polygon, it's straight lines. For some graphs, you need to use a curved line. Okay? Okay, question 6. Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs for 40 minutes at an average speed of 9 miles per hour. It takes Amy 45 minutes to run the same total distance that Jessica runs. Work out Amy's average speed. Give your answer in miles per hour. Important thing to note, it's a speed question, average speed question, number 1. Number 2, the question has to tell you, give your answer in miles per hour. Make sure the unit of your time is consistent with the units of your speed. Okay? Okay, so 15 minutes to an hour, that's 15 divided by 60. use your calculator, is 0.25 hours. 40 minutes to hours, 40 divided by 60 is 2/3 hours. I'm leaving it as a fraction because I don't want to make a mess with decimals. If it's not a recurring decimal, then it's okay to put it as a decimal. If it's a recurring one like 2/3, leave it as a fraction. And we know speed is equal to distance over time. So to find the distance that Jessica ran, we rearrange the formula to find distance. So distance equals speed times time. So we find the distance for both parts of her journey, the first 15 minutes and the last 40. So speed times time in hours. 6 miles per hour times 0.25 hours gives you 1.5 miles. In the second part of her journey, 9 miles per hour times 2/3 hours gives you 6 miles. So Jessica ran in total 7.5 miles. Now to find Amy's average speed, we have to do distance divided by time, but Amy's time is in minutes. We need it in hours. 45 minutes is 45/60 hours, which is 0.75 hours. So Amy's average speed is 7.5 miles divided by 0.75 hours, which is 10 miles per hour. Okay? Okay, question 7. The diagram shows rectangle STUV, TQU, and SRV are straight lines. All measurements are in centimeters. The area of trapezium QUVR is 8 centimeters squared. Show that A is equal to 2x squared plus 20x. Okay, so that's just finding the area of the trapezium QURV in terms of x. So this is all about area of a trapezium. And also a bit of algebra as well. Okay. Now, because STUV is a rectangle, okay, SRV, the full length, is 3x plus 5, or 5 plus 3x, okay? STUV is a rectangle, so that means SRV has the same length as TXU. That means TXU has a length of 5 plus 3x as well. But need to know the length of QU. And the length of QU is going to be the length of TQU minus TQ, which is 5 plus 3x, which is the length of the whole thing, minus this length, 2x. 5 plus 3x minus 2x for QU, that's 5 plus x. And the formula for the area of a trapezium is half 0.5 a plus b, which is the top bit, plus the bottom bit, times the perpendicular height h, in this case 4x. TS is the same as UV, so that's 4x. So you put in those values, 5 plus x for QU times the perpendicular height, which is 4x, times 0.5, which is half. And so we add that in the bracket, that's 10 plus x. Outside, 0.5 times 4x is 2x, times 10 plus x in the bracket. And so we open the brackets with normal expansion. 2x times 10 is 20x, 2x times x is 2x squared. And we can write it so it looks like what we're showing. 20x plus 2x squared is the same as 2x squared plus 20x. And A is equal to that. So that's the area of the trapezium QUVR. We just found the area of that. Okay. Okay. Question 8. An electricity company charges the same fixed amount for each unit of electricity used. David uses this graph to work out the total cost of the electricity he has used. That's the graph. Work out the gradient of the straight line. Okay, so to find the gradient of any line, you have to pick 2 points on the line and state their coordinates. So x-axis value first, y value second, so y-axis value second. So that's 100 to 14. So that's 12 to 16, halfway through. That's 14. And then B, that's 20. At that point, that's 2.8. If you don't know how I got that, the scale increases by 4. There's 10 small squares, so 4 divided by 10, so it's going up. For every small square, you go up 0.4. So if you count up, you get to 2.8 at that point. And so, gradient of a line is changing the values on the y-axis divided by the change in the values of the x-axis. So on the y-axis, you have cost, so that's 14 minus 2.8 divided by 100 minus 20. 11.2 divided by 80, you have 0.14. Okay. And part B, it says, what does the gradient of this line represent? The gradient of the line represents the rate of change of what is on the y-axis with what is on the x-axis. So in this case, it's the rate of change of cost with the units of electricity used. Okay, so the gradient is always the rate of change of what is on the y-axis with what is on the x-axis. Cost with units of electricity used. Okay. Okay, question 9. Express square root of 10 to the power of 360 over 10 to the power of 150 times 10 to the power of 90 as a power of 10. Okay, now, if you just plug this into your calculator and get this answer, you get an answer mark, but you don't get method marks. So, that's why you have to show a process. Now, we've got to break this down slowly. This is in two forms. We need to bunch this up. So, if you're multiplying two things that have the same base, which is 10 and 10, laws of indices states you just add the powers. So that'll be 10 to the power of, that's what that means, that sign means, 10 to the power of 150 plus 90. That bottom part, the denominator simplified, is 10 to the power of 240. Now, that'll be 10 to the power of 360 divided by 10 to the power of 240. Laws of indices state, if you're dividing with the same base, you subtract the powers. So that's 360 minus 240. That's 10 to the power of 120. So, now you have square roots. You've simplified everything in here to 10 to the power of 120. Square root in laws of indices is like multiplying your power by half. It is multiplying your power by half. Okay, so that's 10 to the power of 120 times 0.5. Or you can write it as 1 over 2, which is equal to 10 to the power of 60. Okay, this is all based on the law of indices. Okay, square rooting is like writing a number to the power of a half. When you're multiplying two things with the same base, you add the powers. when you're dividing two things with the same base, you subtract the powers, and there's more of those laws of indices for you to have a look at. Okay. Part B. Liam was asked to express 12 to the power of 50 in brackets to the power of 2 on the outside as a power of 12. Liam wrote 12 to the power of 50 in brackets to the power of 2 is equal to 12 to the power of 50 and 50 to the power of 2, which is equal to 12 to the power of 2,500. Liam's method is wrong. Explain why. Well, the easiest way to explain why is to show how to do it the right way. And that way it's explained. Okay, this is a math paper, not a literature paper. Okay, so show it with math the right way to do it, and you explain why he's wrong. Okay, so show the right way to do it, which is 12 to the power of 50 in brackets to the power of 2 is basically 12 to the power of 50 times 2. Not 50 to the power of 2. 50 times 2. So you multiply the powers. That's another law of indices. And then you get 12 to the power of 100. That's the correct answer. And by showing the right way to do it, you've explained why Liam is wrong. Okay? Okay, question 10. Jane bought a new car 3 years ago. At the end of the first year, the value of the car had decreased by 12.5%. The value of the car then decreased by 10% each year for the next 2 years. At the end of the 3 years, the value of the car was £17,010. Work out the value of the car when Jane bought it 3 years ago. Okay, so I said let the original value of the car be T, because I don't know it, let's represent it with a letter. Now, after the first year of decrease, it decreased by 12.5%. So that means the remaining value of the car is 1 minus 12.5 divided by 100, which is 0.125. So 1 minus that times T. So 0.875 T is what's left after the first year. And says, for the second year, the value of the car then decreased by 10% each year for the next 2 years. So we'll do the second year first, decrease by 10%, which would then be 1 minus 10 over 100, which is 0.10, times this reduced value from the first year, not the original value. So that would be 0.9 times 0.875 T, which would give you that. Okay? And for the third year, it also reduces by 10%, which is 1 minus 0.10 times what I got at the end of the second year. That's 0.7875 T. So that's 0.9 times 0.7875 T. And you get 0.70875 T. Now, after 3 years, this is what you get. 0.70875 T. But you also know what the value of the car is after 3 years. So that means 0.70875 T is equal to £17,010. So, equate them to each other, and you need to find T, which is the original value of the car. So you divide both sides by 0.70875. If you do that to the right, all you have left is T. Do that to the left, put that into your calculator, you get 24,000. Now, you can either write £24,000 equal to T, or you can switch it up. still says the same thing. If x is equal to 6, that means 6 is equal to x. Same thing here. If 24,000 is equal to t, then t is equal to 24,000. I just switched it up. You can write it the other way as well. Okay? Okay. Question 11. Raheem has 16 shirts, 5 pair of jeans, 3 jackets. Raheem chooses an outfit to wear. An outfit is 1 shirt, 1 pair of jeans, and 1 jacket. Work out how many different outfits Raheem can choose. 16 shirts, 16 possibilities of shirts, 5 possibilities of jeans, and 3 possibilities of jackets. Pretty straightforward. Okay, this is a combination question. So the number of possibilities you can have. You have 16 possible shirts times 5 possible pair of jeans times 3 possible pair of jackets, which makes for 240 different types of outfits. Okay? Okay. Question 12. ABC and ACD are right-angled triangles. DC is equal to 8 centimeters, angle ADC is equal to 45 degrees, angle ABC is equal to 20 degrees. Work out the length of AB. Give your answer correct to 3 significant figures. Okay, we have right-angled triangles, we have angles in there. You're going to be calling on Succatoire. Okay, so we start with finding AC because we have no length on the triangle ABC. Thus, we don't know the length of any side. So we have to find the length of a side. We can find AC. So we use Succatoire. So DC we know is 8 centimeters. And we have an angle ADC. 8 centimeters. The side DC is adjacent to the angle ADC, meaning the angle 90 and the angle lie on that line. They're both on that line. So that's the adjacent. And AC is opposite to angle ADC. Literally, it's looking at it. So if angle ADC was an eye, you would be looking at its opposite, which is AC. So we have opposite and adjacent. So we use TOA. TOA, opposite and adjacent. So that's tan. So tan of the angle ADC, which is 45, is equal to opposite AC, which we don't know, over adjacent, which is DC. So tan 45 is equal to AC over 8. So if we rearrange this, we get AC is equal to 8 times tan 45, and the AC is equal to 8 centimeters. How do we rearrange? 8 is at the bottom, so we multiply both sides by 8. And we get AC is equal to 8 centimeters. Now we have the length of one side on the triangle ABC. So now we can find AB. AB is the hypotenuse, which is also the longest side. The angle ABC is looking at the side AC, which makes the side AC opposite to the angle ABC. So we have opposite and hypotenuse, that's OH, which makes sine the viable option. So in the Succatoire, so sine of the angle we used to find our opposite and its hypotenuse. So that's angle ABC, sine 20 is equal to AC divided by AB, the hypotenuse. So sine 20 is equal to 8 over AB. So if we rearrange, we get AB is equal to 8 divided by sine 20. Okay, and AB is equal to 23.4 centimeters to three significant figures. If you do that in your calculator, you get 23.3904352. And if you round it to three significant figures, you get 23.4 centimeters. And you fulfill what the question has requested. Okay. Okay, question 13. A and B are vectors such that A is equal to 2 minus 3, and 3A minus 2B is equal to 8 minus 17. Find B as a column vector. Column vector just means you write it vertically as opposed to horizontally like a coordinate system. Okay, so we know what A is, and it says 3A minus 2B is equal to 8 minus 17. So, let's find 3A. So 3A is 3 times 2 and minus 3, which is 3 times 2 and minus 3, which is 6 and minus 9. So, we can plug that into this equation here. So 6 comma minus 9, because I'm writing it horizontally instead of vertically. So 6 comma minus 9 minus 2b is equal to 8 comma minus 17. So if I rearrange this, move 2b over to the right, make it positive, move this over and subtract it. So 6 comma minus 9 minus 8 comma minus 17. So that minus affects both the 8 and the minus 17. So that's 6 minus 8, that's the x coordinate, and minus 9 minus the 17. So 6 minus 8 is minus 2, minus 9 minus 17 is minus 9 plus 17, still equal to 2b, and minus 9 plus 17 is 8. Okay, and so you divide both sides by 2, and that 2 has to divide both coordinates. Okay, so that's minus 2 over 2, 8 divided by 2 is equal to 2b over 2. And from that we get minus 1 comma 4 is equal to b. And as a column vector, the way you write it is vertically without any commas, like that. So b is equal to minus 1, 4. Okay? Okay, so factorize fully 4p squared minus 36. Okay. Okay. First things first, there's a common factor between 4p squared and 36, that's 4, so I take that out, and I have p squared minus 9. So p squared minus 9, that's p squared minus 3 squared, so that's a difference of 2 squares. So we can break that down again and factorize 4 bracket p minus 3 bracket p plus 3. Okay, so let's factorize fully. Final answer that is. Okay, and part B, let's show that n plus 4 bracket 2n minus 5 bracket 3n plus 1 can be written in the form am cubed plus bm squared plus cm plus d, where a, b, c, and d are integers, meaning whole numbers. First things first, you have to multiply any two brackets first, and then simplify that, and then multiply the third one. I just make my life easy, multiply the first two, simplify that, and then multiply by the third one. So m times 2m is 2m squared, m times minus 5, that's minus 5m, plus 4 times 2m, 8m, plus 4 times minus 5, that's minus 20. and we have the 3m plus 1 to the side. So when we simplify that, we have 2m squared plus 3m minus 20. And then we multiply by 3m plus 1. 3m times 2m squared is 6m cubed. 3m times plus 3m, 9m squared. 3m times minus 20, minus 60m. And then 1 times all these 3 is just themselves, so they just fall in 9. And when you simplify, you have 6m cubed plus 11m squared minus 57m and minus 20. Okay? Factorizing, expanding of brackets, topics right next to each other. Okay? Question 15. PQRS are 4 points on a circle. PXR and SXQ are straight lines. Proves that triangle PQX and triangle SRX are similar. Okay, so this is generally a circle theorem question. Now, first things first, angle PXQ and angle SXR are vertically opposite angles, so they're equal to each other, and that's why it's important that PXR and SXQ are straight lines. So they cross each other, so that angle is equal to that one. Vertically opposite angles equal to each other. And angle PQX and angle SRX, they're equal to each other because they're angles in the same segment and they're always equal to each other. And the same thing for QPX and XSR. These two angles, they're also angles in the same segment and they're equal to each other. So, therefore, because PQX and triangle SRX have the same angle sizes, okay, you can say they are similar. Okay, circle theorem mixed with angles and conditions for similarity of shapes. So similar shapes. Those three topics boiled up into one question. Okay, if you want to review from a textbook, those are the three topics you should be looking into. Okay. Okay. Question 16. P is equal to square root 2e over f. E is equal to 6.8, correct to one decimal place. F is equal to 0.05, correct to one significant figure. Work out the upper bound for the value of P. Give your answer correct to three significant figures. You must show all your working. Okay, so to find the upper bound of P, which means the largest possible value, because we're dividing E is on top, F is on the bottom, to get the largest value from this expression, E has to be the largest it could be, and F has to be the smallest it could be, to get the largest possible value of P. So, for E, we go to the upper bound. Because it's correct to one decimal place, we go to the highest possible two decimal places E could be, which is 6.85. For F, or just less than 6.85, but we'll use 6.85 because the upper bound for E is 6.8 plus 0.05. The lower bound would be minus 0.05, but you only need the upper bound. And the smallest value of F, for being one significant figure, the lower bound would be 0.05 minus 0.005. That's the lowest possible value it could be. That if we round it to one significant figure, we'll get 0.05. Okay, so once we have the upper bound of E and the lower bound of F, we put that into the equation. Square root of 2 times E divided by F. Put that into your calculator, and it vomits an answer of 17.44833,644, which you can round up to three significant figures as 17.4. Okay, this is mainly an upper bound and lower bound question. Okay, it's about finding the possible ways to get the largest possible value and the lowest possible value of an expression. Okay, that's the topic to look at for this one. Okay, question 17. The table gives information about the distances in miles that some Year 10 students live from school. So, we have a range of distances and the frequency, so the number of students that live in that range of distance away from the school. Okay. A says, on the grid, draw a histogram for this information. Frequency density against distance. Okay, so we want to construct a graph of frequency density against distance, and it's a histogram, so that means each bar is right up against the previous one. Okay, so how did we get this? Frequency density is achieved from the frequency and the class width. So frequency density is equal to frequency divided by the class width. I have found the class width on the left, which is the higher value minus the lower value. So the class width for the first one is 1, for the second one is 0.5, third one is 0.5 as well, for the fourth one it's 1, for the fifth one that's 2. And then to find the frequency density, that's the frequency divided by the class width. 90 divided by 1 is 90. 48 divided by 0.5 is 96. 22 divided by 0.5 is 44. 8 divided by 1 is 8. And 12 divided by 2 is 6. That's the frequency density. And then you apply a scale. There was no scale here, so you apply a decent scale. The highest value you have for frequency density is 96, so it's reasonable to have your highest value as greater than 96. So I took 100, so went 20, 40, 60, 80, 100, so a consistent scale. And then the first bar, 0 to 1, goes up to 90, halfway between 80 and 100. 1 to 1.5, that's 96. So that's 3 up because 20, there are 10 spaces from 0 to 20. So it's always jumping up by 2 for every small box. So 3 boxes up from 90, you have 96. And then 44, same thing. You jump 2 boxes up from 40, you get to 44. For 1.5 to 2. And then for 2 to 3, that's 8. So 1 box down from 10. And then 6, another box down from 8. So you get 6 from 3 to 5. Okay, this is a histogram frequency density graphs. That's the topic to look at for that one. Okay. And for part B, it says the histogram below shows information about the distances in miles that some year 11 students live from school. The number of year 11 students who live between 1 and 2 miles from school is n. Find an expression in terms of n for the number of year 11 students who live between 3 and 5 miles from school. Okay, so from the question it says the frequency for 1 to 2 miles is n. Okay, that's the number of year 11 students who live between 1 and 2 miles from the school is n. And we can find the class width. Since it's 1 to 2, we know the class width is 2 minus 1, which is 1. That means the frequency density, which is frequency divided by class width, is n also. So that means this is n high. Okay, the height of this is n. That is 15 small boxes. Okay, that creates n. That means one small level, okay, one small box jump on the frequency density scale, on this scale, is n over 15. Okay, so for 3 to 5, that's 1, 2, 3 up. So on the frequency density scale, that's 3 times n over 15. So that's just n over 5. That height is n over 5. If this height from 1 to 2 is n, then that height, which is just 3, that's 15. That one is n over 5. Okay? And that's the frequency density. And if we rearrange the frequency density formula to find frequency, frequency is equal to frequency density times class width. And for 3 to 5 miles, the class width is 2, which is 5 minus 3. The frequency density we know is n over 5, which is 3 levels up. So, to find the frequency, which is also the number of year 11 students who live between 3 to 5 miles from the school, it would be the class width 2 times the frequency density, which is n over 5 for 3 to 5 from the graph. So that's 2n over 5, or 2 over 5 times n, and 2 over 5 as a decimal is 0.4. So either 2 over n over 5 or 0.4n. Okay. Quite loaded, but takes practice and understanding of this whole topic and the formula of frequency density. Okay. Okay. Question 18. Here is a prism A, B, C, D, S, P, Q, R. The base ABCD of the prism is a square of side 14 centimeters. T is the point on BC such that BT ratio TC is equal to 4 ratio 3. The cross-section of the prism is in the shape of a trapezium of area 147 centimeters squared. CR is equal to 12 centimeters. Find the size of the angle between the line ST and the base ABCD. Give your answer correct to one decimal place. Okay, So for this question, what we need to find is the length of DT and the length of SD. That angle between SD and DT is 90 degrees. We just need to find those two lengths, and then we can use tour of secoutoir to find that angle, and that angle will represent the angle between the line ST and the base. Okay? Because DT is the line on the base, and it's the line that connects T back to this. Okay? There's so much important information in the question that should be underlined as you read the question. First things first, ABCD is a square. So if that's 14, that's 14, that's 14, that's 14. Second thing, T is the point on BC such that BT has a ratio to TC of 4 to 3. So BT is 4 over 4 plus 3 times 14. So BT is 8 and TC is 6, using ratios to break them down. Okay. So, and we also know that DC is the same as AB because that's a square base. So that's 14 centimeters. Now we can use Pythagoras because that's a right angle triangle. We can use Pythagoras to find DT, the length. So DT squared is equal to DC squared plus TC squared. And DT squared is equal to 14 times 14 plus 6 times 6, which ends up with 232. And if we square root both sides, we find DT at 15.232 centimeters. Why 3 decimal places? Because the final answer needs 1 decimal place. So any number you take from your calculator should be more than what the answer requests, except when you have to round up for the final answer. Okay, so we found the length of DT. Now we need it for SD. The question also says the cross section of the prism is in the shape of a trapezium of area 147 centimeters squared, and CR is 12 centimeters. So this is the cross section of the prism, PQAB, but also the same as SDRC. Okay, and the area of a trapezium is half A plus B. That's the top length times, that's the top length plus the bottom length, so SD plus RC times the perpendicular height, which is DC. So we've written a formula there, and that should be equal to 147. So with back analysis, so that's 0.5 times 14, that'll be 7. SD we don't know, RC we know is 12. Okay, and so we have 7 times SD plus 12. So we divide both sides by 7 to get rid of 7 outside the brackets, and then we subtract 12 from both sides to find SD on its own, which is 9 centimeters. Now we found SD and DT. So all we have to do is represent the angle between ST and the base ABCD with a letter. So I'm representing it with R because we haven't found it yet. So to do that, because that's a right angle triangle, STD is a right angle triangle, and we need to find that angle there. That's the angle R we need to find. So that tan r, because we have opposite to the angle SD and adjacent to the angle DT. So tan r is equal to SD over DT. And we know the length of SD is 9, the length of DT, we found it here. And so we just do tan arc, or tan to the minus 1 of 9 over 15.232. You punch that into your calculator, you get r is equal to 30.57719917, and all you need to do is round off to one decimal place at that point, which r is equal to 30.6. So you can state the angle between the line SD and the base ABCD is 30.6 degrees. Okay, that was a lot of work involved there. This is not something you jump to, you build to it. There's a lot of topics involved here. So area of a trapezium, there's circuitoir, there's Pythagoras. Okay? There's little things like understanding the properties of a square. Okay? So go back to the individual topics and make sure you understand those. Once you do that, then you'll be able to understand this process. Okay? And then finding the angle between a plane or a flat surface and a line that follows through right behind the individual topics. Okay? Okay, question 19. Show that 3x over x plus 2 minus 2x plus 1 over x minus 2 minus 1 can be written in the form ax plus b over x squared minus 4, where a and b are integers, meaning whole numbers. Okay, algebraic fractions. That's the topic for this. Okay, so we find the LCM of all the denominators, and in this case they're singular, so we multiply all of them together. So x plus 2, x minus 2, and in the case of minus 1, it will just be an invisible over 1, so it will just be x plus 2 and x minus 2. Okay, so this is the LCM. We have it under here. Now, x plus 2 times x minus 2 divided by x plus 2 will just be x minus 2, and that will be multiplied by 3x. So we have 3x bracket x minus 2. For the next one, x minus 2 cancels that out, so we multiply 2x plus 1 times x plus 2. But remember, there's a minus sign in front, so we keep that minus sign outside. And the same thing here. It will be minus 1 times the whole denominator. Okay? Or you could use the method where you multiply all the denominators together. Okay? That way it's easier. So multiply all the denominators together, put it at the bottom, and for the top, how you get this is 3x over x plus 2 times the whole denominator. X plus 2 cancels out x plus 2, and you get that. Okay? But once you get this, it's just about expanding the brackets. So 3x squared minus 6x. All of the expansion of this stays in a bracket because this minus sign is still in front and it has to affect everything that has been expanded. So when you expand all of that, so 2x squared plus 4x plus x plus 2, and they have minus 1. And when you expand that, you have x squared plus 2x minus 2x, that's 0, and then plus 2x minus 2, plus 2 times minus 2, that's minus 4. But that stays in a bracket because you still have this minus 1 outside here that needs to open the brackets or be multiplied into the brackets. So you have 3x squared minus 6x, and that's simplified now, so you have 2x squared plus 5x plus 2. And then you open this one, multiply the minus 1 in, so you have minus x squared minus 1 times minus 4. That'll be plus 4. Okay? And then expanding multiplying the denominators together, x plus 2 times x minus 2 is just x squared minus 4. Same thing we got there. Okay? And so when we open that bracket with the minus sign, we have minus 2x squared minus 5x minus 2. So we just multiply everything by minus. And because they're all positive, they all go negative when the bracket goes away, and they're all multiplied by the negative sign outside. Okay? From there, collecting like terms, so 3x squared minus 2x squared minus x squared. That's 3x squared minus 3x squared. That's 0, so that goes. Minus 6x minus 5x, that's minus 11x. Minus 2 plus 4 is plus 2. And at the denominator, x squared minus 4. So we have that form. Ax plus b divided by x squared minus 4. Okay? And please don't write your squared down below like this. Okay? Always write it like that. Small to the right hand corner. Visible enough, but small to the right hand corner of the number. Okay? Now, there's a process to this. This is a complex question. So, there are much simpler ones. If you start with on the topic in your textbook, you go from simple to more complex stuff. So, if you're looking for the topic, it'll be algebraic fractions. Okay? So start there, do simple questions, get better, ask questions on the topic in general from your teachers, from your tutors, before you jump on an exam question like this. Okay? So that you don't break your confidence. Okay, question 20. The profit made by a shop increases each year. The profit made by the shop in year N is Pn pound. Given that the profit made by the shop in the next year is Pn plus 1 pound, then Pn plus 1 is equal to APn plus 800, where A is a constant. The table shows the profit made by the shop in 2018 and in 2019. Work out the profit predicted to be made by the shop in 2021. Okay, so Pn is the year before, Pn plus 1 is the year just after. Okay, and that's the formula given there. So for 2018 and 2019, Pn is 24,000, Pn plus 1 the year after is 29,600. So we can use that to find A. So 29,600 equals A times 24,000 plus 800. So you simplify that and solve that linear equation to find A, and you find A as 1.2. Okay? Once you find A as 1.2, now your formula takes shape. So it's Pn plus 1 is equal to 1.2 Pn plus 800. So for 2020, Pn is the profit in 2019. So that's 1.2 times 29,600 plus 800, and you get your answer. It's a calculator paper, so just make sure to write this and then write the answer. Don't just jump straight to the answer, you have to show process. And then for 2021, 2020 profit is now Pn, so same again, 1.2 times 36320 plus 800, you have £44,384. Okay, and that's your final answer, because we're looking for 2021. Okay, Ray has 9 cards numbered 1 to 9. Ray takes at random 3 of these cards. He works out the sum of the numbers on the 3 cards and records the result. Work out the probability that the result is an even number. Okay, so the only way to get even numbers from summing 3 cards that you pick is to pick all 3 even numbers, or to pick 2 odd numbers and an even number. If you don't trust it, check. If you pick 3 odd numbers and you add them together, okay, the first 2 will create an even number and the third one will take it back to an odd number. If you pick 2 even numbers and an odd number, the 2 even numbers will create an even number. The third odd number will create an odd number for the sum. Okay? So to have an even number when you're picking 3 cards to sum, they have to be all even, so 2, 4, 6, or any of the above. Or you pick 2 odd numbers, when you sum them, that gives an even number. When you add an even number to that, it remains even. Okay? So these are the possibilities. It's like flipping a coin 3 times. Okay? You either pick all even numbers, or you pick an even first and 2 odds, an odd, even, odd, or odd, odd, even. Okay? These are all possibilities. They look like the same, but since we're not replacing the cards, the possibility can come in different forms. Okay? Even, we don't need to change the setting, because we really can't. But they're similar, so the position of the even number can change. But for the odds, we're not switching between the 2 odds. Okay? So, for the even number, the probability of the first even number being picked is 4/9. The probability of the first odd number being picked is 5/9. The reason why I'm only showing the first one is because the probability begins to reduce as you pick a card. So for 3 even numbers being picked, the first one is 4/9. Once you pick that, that means there's one less even number. So now there's only 3 even numbers left and there's only 8 cards left. So that's 3 out of 8. When you've picked the second one, there are only 7 cards left, only 2 even numbers left. Makes it 2 out of 7. Multiply that together, because it's an even number, and an even number. That's 1/21. An even, odd, and odd. Okay. 4/9. Now you've picked one card the number of cards down to 8, but the odd numbers are still 5. Once you pick the first odd number, the number of odd numbers goes down, and you also reduce the total number of cards. The same thing happens for odd, even, odd. The same thing happens for odd, odd, even. Okay? It's probability without replacement, so they don't replace the cards. So the total number of cards never goes back. 2, 9, goes down 8, and then 7. And you pick the third card. Okay? So when you're done, the possibilities are that, or that, or that, or that. So you add them all together, and you end up with the total probability, which is 11 over 21. Okay? The tree diagram probability, understanding of that, will help with this bit. So flipping a coin 3 times and finding the possibilities of 2 heads and a tail, that sort of thing. So, once again, the individual topic. Understanding the individual topic first is important, which is probability. Tree diagrams all form of probability. Understanding that individual topic before you take on an exam question that bunches up a little bit more in there. Okay. L is a straight line with equation y equals 2x minus 5. C is a graph with equation y squared equals 6x squared minus 25x minus 8. Using algebra, find the coordinates of the points of intersection of L and C. You must show all your working. Okay, final question. The question's already told you. One of the topics involved algebra. And we'll find out the rest as we solve through the question. Okay. To find the points of intersection of a line and a curve, or 2 lines, it's a simultaneous equation. But mainly with a line and a curve, that simultaneous equation can only be solved by substitution method. Okay? So we already have y equals 2x minus 5 as the equation of the line. So I put that as equation 1 and equation 2. So I just substitute equation 1 into equation 2. So anywhere I see y, I put 2x minus 5. So y squared, I put 2x minus 5 squared. So I multiply that and open that bracket. So that's expanded. And I collect like terms and have a 0 on the left. So once you do that, that creates a quadratic equation. So now you've got to find the roots of x. So factorize and find the roots. So you factorize 2x squared minus 5x minus 33. You end up with x plus 3 and 2x minus 11. If you're not sure if your factorized values are correct, expand, and if you get back here, that's correct. Okay? So you just equate both brackets equal to 0, and you find the values of x. That will be the x coordinates of the 2 points of intersection. So x is equal to minus 3, and x is equal to 11 over 2. Or you can write 5.5. I don't like it as a decimal. I like to keep it as a fraction. Now, once you find your x values, you need to substitute back into one of the 2 equations to find your y values. Equation 1 is easier, so I substitute back into equation 1. So when I substitute minus 3 in, that's 2 times minus 3. That's minus 6 minus 5, that's minus 11. And when I substitute 11 over 2 in to equation 1, that's 2 times 11 over 2, that's 11, minus 5, that's 6. So the coordinates, I write it in brackets x to y, and make sure you bunch up the proper ones. Don't go 11 over 2 to minus 11 and think you'll still get the marks. No. Make sure it aligns. The value of x that gives you the value of y, you put it together. So minus 3 comma minus 11 and 11 over 2 comma 6. Okay? So those are the coordinates of the points of intersection of the line L and the graph C. Okay? So this is where we're done. And as always, remember, there is no way you can jump straight to past papers without understanding single individual topics, making sure you understand it, and you can do the toughest question possible on those individual topics. Then you can progress to past papers, not even doing them individually, but practicing them. You're not going to get them right the first time, but even when it's explained to you, because you understand the individual topics, you can make sense of the explanation. Okay? So, individual topics first, before we move to past papers. Okay? Okay.